All right, so let's get started. This is typically a 1 hour, 15-minute session when I do it, so I've streamlined a lot. But if we could hold the questions to the end, I'll take them to the side. We've only got an hour. I'll be around for like half an hour after the session. Anyhow, today's session, as I said, was about building real-world Windows 8.1 apps using Windows Azure mobile services. So what this really is all geared to do is to basically show you how you can, it's interesting that I forgot my agenda slide. Let's do some real live. It's interesting what you miss when you review your slides. Okay, so what this is really about is how to take the next steps when you're building a mobile service application. There's a lot of things developers will stumble on. A lot of the demos we've done in the prior sessions, they're sort of the getting started, the quick few simple lines of code that get you a result fast. This is more about how you go and sort of extend past that for building real-world apps. So I'm going to show you, as a prerequisite, I assume you've all done the getting started for our new mobile service, or at least seen it. But I'm going to show you how you can use source control, typically required when you're doing team development. You don't want to be going and editing scripts in the portal when another one of your devs on your team may be trying to edit the same script. I'll show you how you can use NPM to actually pull down modules that provide functionality that's not in-box for mobile services. With respect to auth, the expectation here is that you've already seen the configuration of auth before. So we're going to take it from that starting point where you've got an auth flow implemented, and we're going to look at how you can do things like filter user data, as well as cache credentials so you don't always get a login dialog. From there, we'll jump to geolocation and look at things like how to figure out in a Win 8.1 app, where am I? How do I put that on a map? How do I add places or points of interest to my backend service? And how do I perform a radial search back of those points that are within a certain distance of me? We'll look at media from the perspective of how do I capture media in a Windows 8.1 app, and how do I securely upload that to storage using what's called a blob shared access signature. We'll talk about the different ways that you could do it and why a blob SaaS is the most secure. And lastly, we'll look at notifications and live tiles. So for this, I'd like to show you how you can configure both push notifications as well as periodic notifications, and we'll talk about when you choose to use which one. So with that, we should probably get started because there is a lot of content. So let's start with source control and NPM. So within the portal here, I've already got a number of mobile services that I've created. I've got source control NZ here. To create a mobile service, it's called compute mobile service create. This is a deep dive, so we'll expect you've seen that done before. So let's jump into this one, which I created earlier. Now this is the stock default, click create, and you have an output. What I've done here, I've already gone through and I've hit create table to download the quick start, and I've downloaded the quick start app. But apart from that, nothing is different. If I want to enable source control for this solution, simply come to the dashboard and select set up source control. Click OK, click yes, and that will go and configure source control. Now I've already, the first time you do this, it requests a username and password to be able to connect to that, and that applies to all your mobile services. So I've already done this, and that's why it's not asked for those credentials now. So we're going to let this run. Let's jump to the downloaded version of this solution. So I'm just going to hit run on this. It's the simple to-do app, which you should have seen, and there's nothing different from this to what you download in the quick start. For those that haven't seen it, simple task list, task 1, and task 2. Now, in the other sessions, we've talked about how you can use server-side script to manipulate the business logic on the server side when you're pushing data or pulling data back, updating or deleting data. So I want to pull down the source control and manipulate, perhaps, say, my insert operation. So what we can do is let's jump to the portal here. We can see that it's already jumped across to this page. So we've already got our git source control configured. I'm just going to drop into the git shell here. And I'm going to say make dir, and I'll call this server. And I can say git clone, paste in that URL from the portal. Now it requires my username and password. So this will now go and pull down the entire server-side solution as far as what we can go and edit and manipulate down into my local machine here. So I'm no longer having to go and edit scripts, etc., live directly within the portal. So good for team environments. So if I hit, let's see what that's called, and now if I say tree F, we can see that what we've got is we've got our service. If we had any custom API, the scripts would be there. If we had the scheduler, the scripts would be there. If we had shared modules, which are basically script, which can be consumed from anything, be it table scripts, API, or scheduler, that would go there. You can see here that we've got the to-do item table, and you can see that we've got insert, delete, read, and update scripts available here. And the .json is essentially the permissions for those scripts. So let me show you this. To-do, where are we? Service, table. Got a bit of scroll issue here. To-do item.json. So this is our permission set for our scripts. So at the moment you can see that they all require the app key. So you can actually configure that here as well. What we're going to do is we're going to do two things. We're going to cd into our service, and we're just going to say, show you how you can use npm, so node, package manager, to pull down modules that allow you to do things that aren't boxed within mobile service. So this is npmjs.org, so you can search for packages that do all sorts of things here. Perhaps you may want something for Twitter, for sending tweets, within like a single one function call. This one's a simple one. It's something that generates a GUID. And all you have to do is essentially install that package into your service folder. We say node -uid. Now this is going to go pull that package down and drop it into our mobile service. So if we say tree-f now, you'll see that under node modules, we've got node UUID. And we can now start using this directly. So let me find my notepad. And this will be tables, to-do item, insert JS. So within here now, you can see we can edit locally. You could use Sublime, you could use Notepad, you could use VS, whatever you like to edit this. I'm just using Notepad in this instance. But now you can start using that module. We can require it, node-uid, and then we can do things like say item.version is equal to uid.v1. And if we come back to the portal, you'll see that this is a documented module, and if we come down, you'll see usage examples of how to use it. So that's where you can go and find out how to use each of the modules. So we save this, okay, and now we return to our shell, and now we need to go and push this change up to the server. So I'm just going to drop back out to here, and I'm saying, what is it, git add dot. So that's going to go add all those files to be committed. And then we can say git commit, put a message in, node module, okay, and then we can say git push. And with that, that's now going to take those changes and push them directly up to the server. There we go. Just about done. Now if we return to our server script, we can click over to refresh the page. You'll see that now our change is pushed up, persisted, and live. So really useful for team environments. So let's run the app quickly just to see that it is working. So this one should now have with version. Okay, flip back to the portal, hit browse. And you can see dynamic schematization has gone, added the version column to my table, and populated that for the item which we added after the insert script was put in place. So that's source control and NPM support. So the next thing I want to talk about is auth. So the auth workflow in mobile services is exceptionally easy to implement. Who here saw a demo of this earlier this week? Quite a few people. So authenticating users is easy. We won't walk through that. I'll show you where that's been configured though. But the next things people always hit is, how do I restrict access to data based on the authenticated user? And then past that, how do I cache credentials so I don't get the web authentication broker showing up every time I launch the application? So I'll show you how you can do those things. It's a little bit more code than normal. Let's have a quick look. So what I've already done within my mobile service is I've gone and created a Twitter app and essentially copied my consumer key and consumer secret. Then I've gone and configured my identity tab here. Let me select my auth demo. And you can see that down here I've got my Twitter settings. If you wanted to authenticate with any one of these, you just configure the app in the same, in the appropriate identity provider. As far as authenticating user is concerned, it's a simple call to app.mobileservice, so that uses the mobile service client proxy, which you should have seen in the introductory sessions. And with that, we've got a simple overload that takes an enum that identifies the identity provider which you want to log into. So we're just going to use Twitter for now and hit save. So this is sort of the baseline. Let me run this. You can see that already, that was in the on-navigated too. So it's popping up the web authentication broker. It's cached my credentials here to a degree, but I'm still getting this dialog. Hit authorize app, it allows me to connect and then consume the data that I've got within my service. On here, just as a refresher, let me show you how you restrict permissions on your table. We saw in Notepad that there is a JSON file that defines the permissions. If you prefer configured in the server side, there's a simple permissions option here where you can go and change each of the CRUD operations to one of a number of different levels. So what we'll do now is I'm going to show you basically some of the cool new tooling that we've got in VS 2013. This is preview. We released RC yesterday or the day before. I haven't updated it because I don't want to break anything just in case. But you can go and download that online at the moment. The really cool thing which we've done with this, with the Windows Azure SDK, is to drop in Server Explorer a new Windows Azure node, and under that we've got all your different Azure services. So as you can see here, we've got cloud services, mobile services, etc. We're interested in mobile services. So within this, you can do a number of things. You no longer need to go to the portal to create a service, and you no longer need to go to the portal to do things like, say, for instance, create tables, or to edit script. So rather than editing script in Notepad, or say going to the portal to edit script, I'm just going to go and do it directly from within VS here. So I'm going to select my insert script, and what I want to do is I want to attribute the items as they're being inserted with the currently authenticated user ID, and we can do that using the user object here. So I can say item.user ID is equal to user.user ID, and I can say item.level, so this is the user level, level being admin, authenticated, or anonymous, depending on what authentication mechanism the user used. Okay, so with that, that change is live. So let's insert some data. It's still running. With user level, hit save. Let's go and dock that there, go to the portal. There we go. Can't browse data within Server Explorer yet. It's a feature we will add. But you can see now that I've got the user ID and level available. So now you can see this refresh query here is pulling back the data, right? And hello here isn't assigned a user ID. It may well be that another user, logs in, say Diego, with Facebook, and it's got his Facebook ID. Typically, you don't want other users to see other users' data in that, right? Well, it's really simple to go and start filtering data now that we're storing this user ID. Now to do that, we just simply go to the read script, and we can say you've got the same sort of parameters here, except in this case for read, we've got the query. We can say query, where, we can say user ID, so the column is equal to user.user ID. And that will simply update the where query that's coming from the client with an additional and user ID is the currently authenticated user ID. So if we hit save on that and refresh now, you'll see that it's now filtered out to only return back my data. So that's quite straightforward. So let's stop the app there, jump back to the desktop here. Where are you? Here we go. Now if I launch this app again, you'll see that I'm getting this dialog to authenticate. Let me launch it again. And in terms of user experience, the tokens that are returned back from the identity providers, they last longer than like a couple of minutes, right? Depending on the identity provider, it can be like up to 24 hours or even longer. So for many app experiences, people tend to come back and say, hey, the login dialog showing every time, how do I get rid of that? So what we can do is we can use what's called the password vault. So let me jump in here. And we can log the user in the first time, take the credential, store it in the password vault, and then retrieve it when the app starts, and populate your mobile service client with that. So let me show you how to do that. So as we showed before, there's a mobile service client here. Now what we can do is on login, we can make it a little bit smarter. And we can say, if the app.mobileservice current user is null, then we want to authenticate the user. Once authenticated, we want to go and save that credential out. Now we can use password vault for that. I've created a nice little wrapper here with add existing item. Just jump up one level, and this guy in. Now what this is it's a simple class with a few static methods that essentially has an add credential and get credential operation, and I wrap what's called the password vault. I've called it credential locker because there's basically an issue with this name conflicting with someone's trademarked name, so let's refer to this as credential locker. But with the credential locker, what we can do is we can say var vault new password vault. Then we can say vault dot add. So this is my add credential, which takes the username and password. And then we can say new password credential. And then we say resource. So this is basically the key that we want to look it up for. We've got it defined up here as mobile service auth demo, username, and password. And with that, that is now stored in the password vault. The cool thing about this is this will actually roam that credential between your Windows devices. So if you've got a Surface and you've got your Win8 laptop here and you've got the same app installed on both, when you go and save this in there, that password will now roam to your Surface. So if you're logging in with the same Microsoft account on both, this credential will be available on the other machine. So essentially you've got not just caching of that credential, you've also got roaming of that credential between devices. So that's a really nice feature. So we've got our add credential thing here. Now all we need to do is go and save the appropriate credentials. So now let's say credential locker, add credential. Now what is our username and password? So in this case, we'll say current user dot user ID is our username, and app.mobileservice dot current user dot mobile service authentication token, so that's the token returned by mobile services once you've completed your auth flow, is going to be our password.
If you're already logged into your Windows applet or so, would it take your credentials automatically?
Already logged in, well, yes and no. There is, so if you're using Microsoft account, there is an option to enable single sign-on and overload on login async. That only works with Microsoft account. So this is essentially caching our credential now. Now, this logic is still a little bit of demoware because there will be cases where that credential expires, and the code we're going to add is going to ensure this is never null. So what you do need to add is a little bit of logic around, say, your CRUD operations or any call to the service to say, if there's a mobile service exception for authentication, then you actually need to go and log in again because this credential will expire. This code here expects that it never expires, but it's not hard to add that code. So now that we've stored it, the last thing we really need to do is just to rehydrate our mobile service client every time the app runs to set that credential. So I'll use a snippet here just to save some time. So we're just calling get credential, and again, this uses the password vault. So there's our vault. We say find by resource. That's the resource which we named this as our key. The first instance of that under that resource name. If the credential is not null, then to actually get the password of the credential returning back, you have to call the retrieve operation and pass in the username and just pull out password on that. Again, this is somewhat streamlined. You should be checking for nulls and whatnot here. But in any case, that's the bare minimum for that. Now, returning back here, what we do with that, we say is, if it's not null, let's set the mobile service current user equal to a new instance of mobile service current user username, and then let's just simply say the authentication token on that is the authentication token which we originally saved. So let's save this and hit run. So first time, request the password. Authorize that. Okay. Let me kill this. Go back to here. And let's go. And you'll see that now the credentials cached, it's gone, it's pulled the data back from the server, and we haven't had to log in. So it's working fine. So if we come back and say now, is it credential? There we go. Come in here. See, there's our mobile services auth demo, username and credential. So that's what's actually flowed as part of Windows across 2 other devices if roaming is enabled for that particular application. So that is auth. Let's look at the next thing, which is geo. So the thing that I really want you to get out of this demo is not just how the geo APIs work on Windows store apps, but also that all of the data and tables underlying your mobile service are accessible to you from tools which you're familiar with, like SQL Server Management Studio and whatnot. On top of that, you know, in terms of our dynamic schematization, when you pass a JSON object to the service, and then that goes and uses dynamic schema to determine the column types. We've just got simple support for like numerics, strings, and dates at the current point in time. And there are data types available in SQL Server, like geography data type, that are really good for doing things like spatial operations. So in this demo, I really want you to take away, A, you can connect up to your backend DB and manipulate that. And B, you can use data types that aren't supported in the dynamic schematization. We just need to write a little bit of logic for that. And the key things I'll show you in this is how to find out where you are in the Windows APIs, how to save a place of interest up to your service, and how to convert that place of interest to the geography data type, and then how to search for places that are nearby you. So let's jump into that one. I will close this. Who's built a mobile service before? Do you like the idea of having this baked into VS now, so you don't have to go to the portal? Pretty cool? Okay, awesome. Good to hear. So this is my basic app. So if I build this, it's going to fail, right? So this app is basically disconnected. I've gone and removed all references to my mobile service because I want to show you how you can essentially add a reference to the client for an existing application. What's breaking there are basically just using statements to mobile services namespace, etc. So to do this, you can simply go into Manage NuGet Packages, go online, and we can say Windows Azure Mobile Services, search for that. A little bit slower in the network, looks of things. There we go. We can simply come in and install this package. Now that is what we use to go off and connect to our mobile service. It provides all the mobile service client, API and whatnot, which we saw in the last demo. So it's got a number of dependencies here, which it's going and installing. One of the recent things which we just added was basically compression of data to and from the server. And once these are installed, I should have known that this would take too long. Yes, they work on phone. You could also use it from a .NET app. It's a PCL. And we've got client APIs, not just for Windows Store, for Windows Phone. We've got a client SDK for iOS, for Android. We've also got a JS client library if you want to build HTML apps, say if you're building a Cordova app or something like that. Let me show you that while we wait for those dependencies to install. So if you're looking to build something that's not just Windows Store, a good starting place is the Quick Start here. You can see from here you can go down and download the Quick Start apps across all of those client platforms. If you're building embedded solutions, you can actually go off and just use the REST API directly. There's a well-defined spec there. You can do it. Any question while we wait for this thing to install? It's somewhat slower than expected. Yeah, so the auth model is extensible. Basically, what you need to do if you want to use anything outside of Microsoft account, Facebook, Twitter, or Google, you need to implement the auth flow such that, let's say it's LinkedIn, for instance. You auth against LinkedIn, you have that redirect to your own service, which may be a custom API and mobile service. You take that token back, and then you basically have to form that token into the mobile service authentication token type. And that JWT, how we expect that to be, is defined in MSDN as well. So it's certainly possible to do that. In fact, there's a provider or a company or a startup called Auth0, and they've basically gone and added support for mobile services across a whole range of different identity providers out there. So they've provided essentially a boxed means with a simple couple-line API to go off and add identity providers like LinkedIn, etc. But if you want to do it yourself, it's still doable. We've built the API to be extensible. Yeah, AUTHZERO. Yep. Man, this is what's going on, Diego? I'll tie up my shoelace while we wait for this. Excellent. Sorry, bad timing there. I can just see myself tripping and falling off the stage. Okay, so that's installed. Oh, excellent. Okay, so let's run the app. Let's have a look at what we got to start with. At the moment, it's still completely disconnected. And I've sort of stubbed out all of the functionality you're going to see. So we can see that, where are we? First question. At the moment, we're in sort of the middle of the ocean, or 0 lat long. If we come down, you can see that there's this blue thing here, and that's for our radial search functionality to find points of interest that are nearby us. And if I click on here, I can add a place, and this add functionality is essentially where we save those places that we want returned. So let's do the first thing. Let's find out where I am. And we're going to do that here. So what we can do is we can say var location equals geolocator. This is a Windows class in Windows Devices Geolocation namespace. New geolocator. And we say var pos, we'll say pos, what's it called, geopos is equal to locate. Man, can't type this morning. Sorry. Let's get this a bit cleaner. Locator, we'll say await, get geoposition async. That'll return back our position. Now, position here is just a nice little entity that I'm using to represent a location, latitude and longitude. So if we come here and I say var position is equal to new position, and the reason I've done that is I just didn't want the bloat of everything that's returned back in the geo position for this to know. So I can say geopos, then we say coordinate. Now, anyone who's built a Windows 8 app, you'd typically be using latitude and longitude. You can see it's deprecated now. What we've done for 8.1 is we've gone and put all of those values along with a lot more within point. We can say position dot latitude. If we take this, drop this guy here, we can say longitude is equal to longitude. Okay, so with that, we should now get a location. Now, what this should do is it should use the IP address of the network I'm on. My laptop does not actually have, GPS built into it. So you can see that's looked up the IP, it's done a geo IP lookup, returned a ladder long, and it's gone and placed us in Sky City Hotel. So that's, reasonably okay. So that is where am I? Quite simple, only a few lines of code to go and find out that information. So let's look at how we go and do the add place functionality. So, just to be clear, I know about MVVM. I've just kept all the code in the code behind to make it very easy to follow here. But if you want to build a better, more testable and maintainable app, you should use MVVM here. So to perform an insert is extremely straightforward. App.mobile service, get table, the type. In this case, place is my entity that I'm serializing over the wire. You can see title, description, ladder long. And then call insert async and define the place. So you can see I'm just newing up my place here. I've got a property, latitude and longitude on this particular class. So let's go and define this now. You can see this isn't working. So that's because we actually don't have an instance of our mobile services client. So that's easy to get at. You can simply come into your mobile service here. You can see if I say connect an existing Windows Store app, we just go and grab this code, copy it, drop back to VS, and hit save. Now the last real thing that we're doing there is we're inserting a place. And you can see if I expand this guy out, I've already created a place table. And that place table simply has no properties except an ID on it and no real code or any code of any sort other than the default here. So with that, let's run this. I'm surprised I can still speak. And what we can do now is we can add a place. Hopefully I haven't done anything wrong there. That's as expected. And you can see as I'm adding places here, they're actually adding, but I'm not adding them to the map. If you're implementing this as a proper application, you'd go and add the push pin as you add it on the client side, so you don't have to do a round trip. I haven't done that because I just want you to see the effect of performing a radial search on the server through a custom API and pull that data back. So you can see there's the 3 points we just added. Now, as we talked about before, latitude and longitude aren't really it's just being stored as a float in the DB at the moment. They're not really an easy type to work with if you want to do radial search. The geography data type in the SQL Server is much better for doing that. So what I want to show you here is that you can actually go and connect to your mobile service using SQL Server Management Studio. So you can see this is GeoNZ. I've hit configure and you can see that's running on this particular server. So if I click over to the server and select dashboard, you can see that that's the endpoint that we've got. If I jump into configure here, what I've done prior to the session is I've just, by default, your Azure SQL DBs are restricted such that only services within Windows Azure, within your subscription, can connect to them. If you want to connect from an external IP to that, you need to configure a firewall rule. And it's quite easy to do. You can see here there's a current client IP address. So you can simply select copy and add that, or you can go and hit add like this. So we'll just leave that as default and hit save. And that's going to now enable this machine on this IP to go and connect up to that back end. So if I jump over here, the credential or the endpoint is cached. That's my server. I can simply hit my password in, hit connect. And with that, I'll now connect to my logical server in the cloud. So you can see in this East Asia data center, I've got a few DBs, but the one we're interested in is this particular one. Because what we want to do is we want to add a column called location for storing the geography data type. So I'm going to open a recent file I've got here. There we go, and we're connected to the right DB. I'm just going to drop all the data. I'm going to drop the latitude and longitude columns, and I'm going to add a place, to the place table, a column called location of type geography. Okay, so that's good. But now we've got the problem of saying we're pushing up this entity that has two properties, latitude and longitude, but somehow we need to turn that into that geography data type such that we can use the rich functions that hang off that data type to perform our radial search. To do that, simply we can use our server script. So if we go to place and insert, and I'll just say, drop in a snippet here. Now, okay, yeah, normally you wouldn't concat any strings. I'm not doing the parameters there, but I've just done it so it wraps and you can sort of see it a bit easier. But what we're doing on insert is I've got insert into place and values. The values are parameterized. So the first one is the title, the second one's the description, and the last one's the location. And you can see that I'm actually using geography and then the function st_point_from_text that uses a format called well-known text. Well-known text is simply point, longitude, latitude, okay, longitude, latitude like that, and that will turn it into a geography data point. So that's what that's doing there. And as far as the parameters are concerned, I can see item, title, description, longitude, and latitude. I execute that using the MS SQL object, which is one inbox. You use this if you want to execute SQL script directly. If you wanted to make this nicer, you'd turn this into a stored procedure. I'm just doing it here for readability. On success, I return to the client and say OK. OK. So let's save that back up to the server. Let's run our client app and add a point this time. Let's put it out here. There's 1 point. Let's put one in closer. There's 2 points. And let's go back to the server. Select our mobile service again. There it is. And we'll see now that we'll have our data stored within a geography data type. So that's cool. So now let's use this geography data type to implement that radial search that we've got here. So we're going to use a new, or relatively new feature called custom API. So all the stuff we've done so far has been script associated to a CRUD operation. But most devs or most solutions don't always tie, server logic to a CRUD operation. Some will want to execute things like have a send email function or something like that they can call, or a send push notification. Custom API is essentially script you can execute on the server side that does not have to be tied to a CRUD operation. So it's just an endpoint at WAC API you can get at. So let's start at the client side actually and flow all the way across. It's probably a neater way to do it. So let's add the code to call our custom API that we're going to create. Where we go. And it is query places. So again, what we've got here is mobile service. We've got a method called invoke API async. The name of our API, we're implementing a get operation here and providing a filter. Now the filter that I'm getting, essentially origin and radius in kilometers from that origin. To create the filter, I'm just creating a dictionary of strings, and you can see longitude, latitude, distance, and we can actually read them from within our custom API. So let's create that called place. You can actually implement, your get, post, put, patch, and delete operations here. We're only going to use get in this case. So one small limitation at the moment, you'll note that I'm back in the portal here. Currently, the tooling does not allow us to create custom API over in Server Explorer, but that will come as we progress. Custom API place. This is my uber cool snippets that are actually, who likes that? Let me show you the outcome. So it's a favorite that actually executes JavaScript and copies code into my clipboard so I can just paste it in. It makes it easier rather than jumping between jumping between Notepad and whatnot. But anyhow, so this is at my get operation that I can execute. It has a request and response. Now you can see I'm executing a select operation here, and what I'm doing is I'm flattening out that location back into what the client-side entity requires for deserialization, the lat and long. And to perform that radial search, what I'm doing on the geography data type, the location column, I can call st_distance, and then I'm saying st_point from text, and that's actually going to take my query longitude and query latitude from the client side that we passed up in those filter arguments. And essentially we're saying this statement here, and let me zoom out here for a second, the zoom has screwed my scroll. This statement here, location to origin, we're calculating the distance between that. So we're saying where the distance between the location that's stored in the table and the origin is less than our last parameter here, which is going to be latitude, longitude, distance. So that's the distance from the origin, or the radius parameter, which we passed up. On success, respond, else write something to log. So we can hit save on this. And then once that's live, we should be good to go on this. So we found New Zealand. It's executed my invoke custom API and bound that to the UI, and you can see that we've got our two places. If I were to change the radial search here, so that it executes that custom API, you can see it's dropping off the other place. Bigger radius, put it there. Let's add one out here that's not visible. Go out to 5Ks, and you can see that all three are there now. So that's geolocation, essentially showing you can connect with SQL Management Studio to your existing DBs and add functionality that's sort of not in the custom, turnkey type solution. In this case, the geography data type. And lastly, there is sort of demonstrating how you can convert data to those types and then flatten it on the way back out and perform a radial search using the functionality provided within SQL Server. So let's look at the next one here. In 19 minutes. Okay, let's look at media. So Glenn would have done a demo here on this. I'd like to actually show you guys a little bit more around blob SAS and why it's important. But media, I want to show you how you capture that in a Windows Store app, and then how you can securely upload that media to your storage account. So to do that, this blank slide is intentional. I'm going to try my best to actually draw here. So, who here has used blob storage before? A couple people, right. So blob storage is essentially a storage service that we've got in Windows Azure for storing your binary data. By default, a storage account can have up to 200 terabytes of data, I believe. Tera. And in any case, to access your storage account, you have an account name and account key. So if we've got a Win8 client here, one approach would be, we're going to go through a few, you have the account name and account key on the client. Then over here, you've actually got your storage service. So I'm going to call that blob. Sorry about the... I can write. That's blob storage. Imagine that is written a lot better. But one approach would be store the account name and key in the app, connect up, and upload your files to storage. Now this is a bad approach because anyone can basically try to reverse engineer your app, and if they're successful in doing that, they'll take that account name, account key, and then they can go and store up to 200 terabyte of data in your storage account and do whatever they want with it. And that's going to cost you money. So an alternative approach that people use is to say, well, why not just go and sit a proxy service in between? So they may spin up a Windows Azure website with a web API or something like that, and then they may have the account name and account key stored within this. Right, so your app would then authenticate against some known directory of users, and then hit this service and authenticate against that as such. Now, if I then say, let's go and send our file up here through that web API and then store it within blob service, that's one approach that essentially means now your account name and key are safely stored on the server. But there's a problem with this. If you've got hundreds and thousands or tens of thousands of client apps and they're all sending images up at some point in time, these images may be a meg, they may be a video, 10 meg, 100 meg or whatnot. What's going to happen is every machine, including your website here, is network bound. Same as my laptop here, there's a certain network capacity that you can have on this. And if I go and say, hit that network bound, I'm going to have to scale out my web tier to essentially add more network I/O such that I can support sending up more files. And there's a cost associated with doing that. So the problem with this approach is, while it secures your account name and key, you're going to have to scale early to support the bandwidth needs of your application, and that has cost associated. So there is a better way, and that's where Blob SaaS comes in. So what a Blob SaaS is essentially a timebox token that gives you permissions to a resource within Blob storage. And in this case, what we're going to do is we're going to give write permissions for our application to actually go off and write directly to Blob storage. So what you still do is you still have the account name and account key here. What happens is the client will request a SaaS, shared access signature, and that'll be returned to the client. It's a query string. And then essentially the client will have, say, however long you define in that SaaS, say 5 minutes, to actually go and write to the particular container or blob that your logic on the server side here has given it access to. So let's say we get that SaaS. What we do then is we go off and we write those files directly to the storage service using that SaaS. And essentially what that means is now our web tier doesn't have to scale out so early, because what we're doing is we're returning a SaaS which is only like, a couple KB, as opposed to having to hit this and be pushing up, a couple megs per file. Now the storage service has been designed to scale out such that you can go off and push large amounts of data up through it. What's better is any inbound traffic to the storage service is free. You only pay for having that data sit there in the storage account and for pulling that data out. So all ingress is free. So this is a much more cost-effective solution and a better way to essentially not have to scale out early and incur costs on that side. Also secure when compared to the very first variation which I showed you. So let's keep that and let's jump into source here, and we'll select, in this case, my media demo. Now you'll see here that I've got this media service that I created earlier. It's just got a simple media table. Now the first real thing that we had to do, right, was to request that SaaS and then upload the image. But we need to get an image from somewhere. So what we'll do first is we'll create an image, we'll request a SaaS, and then we'll upload using that blob SaaS to our storage service. So for our client app, basically what we need to do is we want it connected, so let's get that done. I'd like to show you a new feature we've added to VS 2013 here called Add Connected Service. I can select Add Connected Service, and I'll actually go and enumerate my mobile services here, and I can say select the one that we're using, which is Media NZ. If you don't have a mobile service, you can simply hit create and it'll go off and create it. So you can see that's gone and dropped in my connection now. So the next thing is actually taking that photo. Now you can use the camera capture API for this. Just to pull us up on time, let's drop in a big snippet here and have a look at it. So the first thing I'm doing is using the camera capture UI. It's available in the Windows devices namespace. And we're saying capture file async, and we can capture a photo or video here. The next thing we do is, if it's not null, we're going to use our media DTO. So that's just the entity that we're using to store that detail on the server side. And you'll note here that's got a container name, file name, a SaaS, and a URL. So what I'm going to use here is I'm going to go and insert this particular media item to the media table, But while I insert it, you can see that I've only set the container and file name. Now, you could use custom API for this, but I want to store a list of all my images on the server side. So what I'm going to do in this particular case is I'm going to generate a SAS on the server side on insert. So you can see this is my insert operation. Item user request. We've got a blob storage account name and key. And then what we do is we basically define a container that we're going to use and a path where we want to store the image. Next thing we use is the Azure Node SDK to get a handle to the blob service or the blob service client, and we say create the container if it does not exist. So a container is like essentially like a folder, with some differences. But in any case, we say create that container if it doesn't already exist. We want people to be able to publicly read those blobs out, but we don't want people to be able to publicly write. And you can't actually do that in blob storage at all unless you're using a SAS or the account key. So on success, what we do is we create a shared access policy. Now this is the definition of that timebox token for the SAS. And we say we want write permissions for 30 minutes from now, for 30 minutes to be able to write to this particular resource. And then essentially we say blob service, get a blob URL. This generates our SAS for this particular container and file. So we're only able to write to a particular file for this 30-minute period of time, after which it expires and you'll get an exception back from the service. And then we're simply setting the item SAS and URL properties here so they turn up on the client side. So let me set a breakpoint here. So after insert, we'll have the SAS, and then what I'm using is the storage client library to go off and essentially use that SAS to go and write that image to storage from a stream. So you can see I create a storage credential here, which is essentially using the query string portion of the SAS URL. And then we create a container, that's the container that we specified, being media in this case. And then we say, let's get the credential. So now we've got a credential, and we can simply say blob SAS credential, so it's using that SAS URL, and upload from stream. And this file stream is essentially our image using OpenStream for read async. So we're going to stream this directly up. And then locally, I'm going to add that here. So let's run this. Need some like elevator music. Here we go. Very simple UI. Hit capture. Hit allow to use my webcam. Hello. It's like me looking at me, looking at me, looking at me, looking at me, looking at me. Okay. That's sort of cool. Okay. And then what I can do here is I can hit OK. And now that should hit our breakpoint. Let me flip back. Okay, and what you can see here is that server script is executed, and we've now got this SAS URL on the end here, or the SAS query string. So let me get rid of this guy and hit F5. Now that's going to go and use that to upload directly to our storage account. And you can see here that it's actually uploaded and also pulled that back down. That's a cool picture. Never expected to get something like that. Okay, so if I now come down to my storage account, we're uploading to Cloud NIC, select blobs, and then we select media. You can see I've used this container before. We're going to copy this URL, and since this was a public read container, we can now go off directly to the web and reference that. Who thinks that's sort of cool? Nice, secure way to upload to storage. So the next thing I'm going to show you relatively quickly here is notifications. So we've got two real approaches, periodic and push. So periodic notifications, you should consider that a poll-based solution, so where the client is polling to the server. Let me see here. So periodic, the client at an interval will poll an endpoint running on your server for a tile or toast XML template. Then what gets returned back is XML, and then your client will update it to show the toast.tile notification. So this is really good for scenarios where, say, you can bear with a polling-based solution that has a granularity of 15 minutes. Applications which, say, for instance, need to be notified immediately when something happens, perhaps messaging or a news alert or something like that, like Bing, can use push notifications. Push notifications is more complex. So you have your Win8 app, and then your application requests from what's called WNS, which is a service Microsoft provides, a channel URI. That channel URI uniquely identifies your app and the tile which you can target. That channel URI gets pushed into a service, in this case a mobile service, and it's stored on disk, in the DB in this case. When your service determines, hey, something important has happened, perhaps it is that, news alert and you want to notify users immediately, you take that, you compose your same XML payload, but then you authenticate against WNS, and WNS will deal with delivering that, and Windows will deal with surfacing it as a tile. So there are two real approaches there, and my general advice would be, if it doesn't need to be, almost immediate sort of delivery, go for periodic notifications, because it's a much simpler sort of solution to implement. You don't have issues with sort of scaling out in terms of the retrieval of those, say, millions of channels, and then figuring out how to sort of parallelize the push of notifications. Instead, the client polls, and you only have to scale out your web tier rather than figuring out that. But if you are sort of considering using the push solution, I'd encourage you to look at notification hubs. You don't have time to go into it today, but certainly worth checking out. Essentially what that is if you're doing broadcast style notifications using push, we've done all the hard work and heavy lifting in terms of performing a scale out infrastructure, and all you have to do is make one HTTP request, and that'll go and deliver notifications to anyone subscribed to that. So I'm just going to create a new solution here. We'll see if we can do this in 4 minutes. Should be interesting. Well, that does. well, that has its fun time there. Let's go over here and start this. You can do it. Okay, let me create a custom API. So this is going to be used for periodic, and we're going to set get permission to everyone. We're going to hit save. So this is going to be our service here that we're polling. Did VS come back yet? I'm just going to say blank Windows Store up. Okay, good. Now, the one thing I want to do as config for this store app is to show you like a new Win 8.1 feature, and that's the square logo. Do I have one here? That's a square logo, so that's a new logo size. So we can send notifications to that, but to do that we need a default logo. So I'm just going to grab one here, which is select a default logo there, and because we're supporting that size, we also have to support the 310 by 150, which is the wide scale. Okay, good. Now, where is my periodic notification? Here it is, and I'm going to say, drop this in. Now this is a very simple implementation. Obviously you'd want this somewhat dynamic based on the client that's calling into it. But essentially what I'm saying here is return back a tile template. This template has some image and some text. So this now with Windows 8.1 apps, you don't need to use Tile Update Manager to implement periodic notifications. You simply set a recurrence and a URI. And then what was it? tilenz.azure-mobile.net API for all custom APIs and periodic. Hit save. Hit deploy. Okay, and now if we come and do this, it's called app2, pin to start. If I set this as a nice large tile, which is the XML payload I'm returning, you can drop that in, and you can see that it's already polled the API, returned back a picture of my colleague getting makeup with an exceptionally large smile, which I like to make fun of him for, but that was for Channel 9 Live. So that's periodic notifications. Really simple, right? Those of you who were in my session the other day, we actually looked at push notifications. We had an issue because my store account was expired, but all the steps we're doing, it was like 15 minutes. In VS 2013, we've got what we call the push notification wizard, and we can simply go in, sign into our Windows Store account, and we can say, hit sign in. And then from here, we simply select the app or the store app we want to associate with. I'm going to say NZ push, hit next. Next thing we do, so that's the client-side configuration done. We need to go and configure the credentials on the server side for our push, and we're going to use tile NZ here. So that includes, where do we store our channels that we've requested for the client? What's that service name? Where do we write the code to say retrieve those channels and send, say, a toast or a tile update? And what we've baked into this is essentially that entire workflow into this simple sort of 1-minute wizard. So for most people, this is like a real sort of savior, because just trying to understand and learn that flow end to end is difficult. Implementing it is somewhat difficult. We've just basically implemented a best practice of this. You can see when I start the app, we get a toast notification straight out of that wizard. Who thinks that's awesome? Save some time. I think we're running right on time here, so I just want to show you the couple things that wizard did. On the client side here, in the app, it's added a reference to our mobile service. And then down here, it's gone off and said, upload the channel. We've dropped in some client code that will essentially request a channel from the push notification manager and insert it to a channels table. So the wizard's actually gone off and created that channels table for us. And it's also gone and added some insert script that on insert will send a toast notification. So really powerful wizard there, save you a lot of time, available in 2013. Now with that, let's close. So today I went through really the things that you need to start considering once you get past the basic 101 of building a Windows Store app that uses mobile services. We looked at source control, NPM. As far as auth is concerned, we looked at how to filter data based on users and cache credentials. In the geolocation perspective, the key takeaways are there. You have access to your data and schema, and you can manipulate that to do whatever you want, even if it's something that's not supported out of the box by mobile services. In this case, we used the geography data type. We also looked at the geolocator class on the client side in Windows 8.1 as a means to find out where you are in terms of your latitude and longitude. I encourage you to look at the new geofencing support that we've built into Windows 8.1, which allows you to work with geofence scenarios. Media, we looked at the bad practices in terms of uploading to storage in a way that's basically not secure, but then we went and talked about how you can use blob SAS as a secure means of uploading images or any binary data. And lastly, we looked at periodic versus push notifications and the new tooling built into Windows 8.1 to do that. So thank you for coming.